Hello everyone, myself Mohammad Imran Ali, a fourth semester. I am here to give a presentation on semiconductor detectors. History of semiconductor detector. In 1965, the first non-nuclear application of semiconductor detectors started to develop. The availability of low noise field effect transistors and their use with silicon detectors at low temperatures realized adequate energy resolution to resolve the characteristics X-rays of most elements. Introduction. First point is in semiconductor detector, the fundamental information carriers are electron hole pairs which are produced along the path taken by the charged particle, primary or secondary, through the detector. By collecting electron hole pairs, the detection signal is formed. Second point, a semiconductor detector in ionizing radiation detection. Physics is a device that uses a semiconductor, usually silicon or germanium, specifically silicon or germanium, to measure the effect of incident charged particles or photons. Principle of semiconductor detector. Principle of operation of semiconductor detectors. The operation of semiconductor detector is summarized in the following points. First point is ionizing radiation enters the sensitive volume of the detector and interacts with the semiconductor material. Second point is particle passing through the detector ionizes the atom of the semiconductor, producing the electron hole pairs. The number of electron hole pairs is proportional to the energy of the radiation to the semiconductor. As a result, many electrons are transferred from the valence band to the conduction band, and an equal number of holes are created in the valence band. Third point, under the influence of an electric field, electrons and holes travels to the electrodes where they result in a pulse that can be measured in an outer circuit. This pulse carries information about the energy of the original incident radiation. The number of such pulses per unit time also gives information about the intensity of the radiation. Theory of semiconductor inductor. The operation of semiconductor detectors is summarized in the following points. Ionizing radiation enters the sensitive volume of the detector and interacts with the semiconductor material. Second point is particle passing through the detector ionizes the atoms of the semiconductor, producing the electron hole pairs. Semiconductor detector types. There are four types of semiconductor detectors. First, silicon detectors. Second, diamond detectors. Third, germanium detectors. Fourth, cadmium telluride and cadmium zinc telluride detectors. Silicon detectors. Silicon based semiconductor detectors are mainly used for charged particle detectors, especially for tracking charged particles and soft X-ray detectors, while germanium is widely used for gamma ray spectroscopy. A large, clean, and almost perfect semiconductor is ideal as a counter to radioactivity. Diamond detectors. CVD diamond is used as a radiation detector for medical and high energy physics application. Major field of application includes medical dosimetry, neutron detectors, UV laser systems, and X-ray and gamma detection. More about diamond capabilities. Germanium detectors. Germanium detectors are semiconductor diodes having a pin structure in which the intrinsic region is sensitive to ionizing radiation, particularly X rays and gamma rays. Under reverse bias, an electric field extends across the intrinsic or depleted region. Cadmium telluride. Cadmium telluride CDTA is a stable crystalline compound formed from cadmium and tellurium. It is mainly used as the semiconducting material in cadmium telluride photovoltaics and an infrared optical window. It is usually sandwiched with cadmium sulfide to form a p-n junction solar PV cell. Formula used in semiconductor detectors majorly the probability per unit time that an electron hole pair is thermally generated is Pt equals to Ct 3 to the power 2 exponent Eg 2 kT, where T is above absolute temperature, Eg is the band gap energy, K is the Boltzmann constant, and C is proportionality constant. Characteristics of the material. At equilibrium, the potential difference across the junction contact potential is equivalent to the full band gap value. The corresponding electric field is E equals to del V. Thus, the direction of the electric field is such that it opposes further diffusion of electrons and holes. Advantages of semiconductor detectors. High counting rate of the order of 5 into 10 to the power counts per second as possible without any difficulty. Second point, they have low sensitivity to gamma background radiation. Third point, they do not need any window for letting the charged particle into the detectors. Fourth point, they have a very good energy resolution. Disadvantages of semiconductor detectors. It includes the disadvantage is that silicon detectors are much more expensive than cloud chambers or wire chambers. Second point, second disadvantage degradation. They also suffer degradation over time from radiation. However, this can be greatly reduced by Lazarus effect, high FWHM. Lastly, application of semiconductor detectors. Semiconductor detectors are used extensively as charged particle and gamma ray spectrometers. Second point, secondly, they are used as their principal application in nuclear medicine is for assessment of radionuclide purity. Third point, semiconductor detectors are widely used in radiation protection. Thank you.